Okay, so here we are. And well, we know that we're in a scale. We are 80 kilograms. We weigh 80 kilograms. And we want to know what does the scale read when the elevator is going up or down, or even when we have like a numeric case. Okay. So first of all, what happens here? Well, you're gonna have your big axis here, and it's gonna go here. Okay. So now I'm gonna draw all the forces that we're gonna have here. Let's know that when you're on an elevator, you don't have like X components, because if you have X components, well, maybe it's the end of the world. And if you're going in an elevator, well, dude, you're in big trouble. But let's think that this is ideal, and we just have a normal force going up, and we just have our weight going down. Okay, and that's pretty much it. So let's settle the equation for this, and we're gonna know that the sum of the components in y is gonna be equal to normal force minus the weight, and that's gonna be equal to something. Okay, so in the first case, that is case A, whenever the is going upwards, this thing is gonna be equal to mass times acceleration. Okay, so we need to know the lecture of the scale. So there we're gonna know that the normal force is gonna be equal to the mass times acceleration uh, plus the weight, and that's gonna be equal to the mass acceleration plus the mass times the gravity. And if we just like make like common terms, it'll be like the mass times the acceleration plus the gravity. Okay, so that's the answer for first part. Uh, for the second part, let me just change colors, maybe purple. And well, here, what happens when the elevator is going down? So once again, we have the symmetry of the forces in y, and well, we have the normal force and the weight going down. But as we're going down, the acceleration is negative, so it's mass times acceleration, and we need to solve for the normal force. So the normal force is going to be the weight minus times acceleration. So this would be mass times gravity minus mass times acceleration. So this would be mass, gravity minus acceleration. Okay, so this is very easy. And finally, we're just gonna face the case in which we have a numeric problem, and we need to know how to interpret it. So we have this part C. Well, we write once again. Well, we know for sure that it's going to be equal to case A, because it's going out up, but the speed is decreasing. That means the acceleration is going to be negative. Okay, maybe you should check a little bit. But whenever you're going slower, your velocity is growing slower, your acceleration is negative. So well, we're going to know that the normal force. Well, no, this can just vanish away. The normal force is going to be equal to mass times acceleration plus gravity. Okay, so from here we know that the mass is 80, gravity is 9.81, but the acceleration, as we're just decreasing the velocity, is 8 meters over a second. That's why it's negative. So this thing, it's gonna be let me do the math for this. Um, just hold on a second. My calculator broke just at this moment. There you are. And it's 80 times 1.81, so it's 144. Okay, so this is going to be equal to 144.8 newtons. So